engineering and R&D departments. He's one of the 3 people that puts on these presentations for all kinds of groups, and he's been in fire protection as a designer and a department head for over 8 years. So what we'd like to do is welcome Jim up here, and I've told him that he's got about 45 minutes to an hour for a presentation. And he's got a couple of videos that have some test information in them afterwards. I thought we would like to see that. Question and answers will be after that. So if you have to leave early, I understand that, but I'd like to let Jim take as much time as he can because he's going to present some interesting and important information to us. And I'd like to be able to get everybody to answer any questions or ask any questions that they might have too. So without anything else, any further ado, I'll turn it over to Jim and say thank you. You need any help getting set up?
Yeah, just a few minutes.
Do anything for you?
Just want to make sure this is my name is Jim Brunetti. I'm with Central Sprinkler Company, and I want to thank you all very much for inviting me. I'd like to talk to you tonight about basically the technology that the fire sprinkler industry has been going through, and what we as a manufacturer have done to put our best foot forward and move into the future. We've got a lot of new products that we've been developing for the last few years that have really changed the industry. I'd like to make sure that everybody here tonight is aware of these products and understand why we went ahead and created them and how they can help everybody make a better fire protection system. Over the last 4 or 5 decades, there's been a heck of a lot of innovative products produced for fire protection. Just for the heck of it, can anyone name a couple things? We started off with a perforated pipe. We've gone a long ways from there. Anyone? How about a thinner pipe? Computers for the CAD system. Groove couplings. All of these things were developed to provide 2 basic things. It had to be more economical to use, and it has to be equal to or better fire protection than what is presently existing out there right now. You could take an ESFR type sprinkler with a minimum end head pressure of 50 psi and put that into your daughter's bedroom. That's going to be great fire protection. No matter what, you're going to put that fire out. But it's not economical for the contractor to use such a pressure-intensive sprinkler. So everything we do as a manufacturer has to take into account both of these factors. We're going to kind of go over quite a few of the products that fall within these categories. And this is everything in fire protection, from one of our new products called the attic sprinkler, to storage type occupancies, to light hazard, ordinary hazard, all the way down to residential. We've got basically a sprinkler for every application. We started producing something called CPVC piping last year. We're actually making it now. Prior to last year, we were buying it and selling it as a secondary sale. One of the things we were trying to do was allow the contractor to use CPVC pipe, a plastic pipe, in a combustible concealed area. The UL listing now calls for that CPVC pipe, and that's located in any place that has fire sprinklers,
it can't be used in that combustible concealed spot. If it does not have fire sprinklers, you can use the CPVC pipe. We thought, well, primarily for your 13R type occupancies or like 3 or 4 story residential buildings, condos, this type of stuff. If you could run CPVC in the attic, that would be the best overall world for the contractor and the owner. Typically, what you have is first, second, and third level of piping, all plastic. It's all feeding the floors below, and then up above in the attic space, the concealed space, you would have to run a steel line because the CPVC will not make the listing for that combustible concealed space. Well, we wanted to change that. So we contracted with UL to run independent fire tests and run the CPVC in the attic space with standard sprinklers. Well, we set our sprinklers out at standard spacing, 130 square feet, and we put our CPVC down at the bottom. Lit a fire. Instead of the sprinklers putting out the fire, what happened is the heat collected at the bottom of the plywood and raced right up the ridge, completely bypassing 3 branch lines. Once it hit the ridge, it pooled and ran down the ridge. It didn't go to the other side of the attic. Well, eventually when the standard sprinklers operated, it was through pure flashover. And by then, the roof assembly was almost gutted. The UL technicians had to put that fire out with a handheld hose. We contracted a framing company to build that attic for us in the UL parking lot of all places. And we had to call this guy back up. Say, hey, we got another contract. We need another attic. We ran 8 different tests with standard sprinklers to get our CPVC listed. All of them failed. Standard sprinklers in a sloped ceiling configuration or a sloped attic configuration just did not do the job. So we took that kind of as a challenge. What do we do about putting this fire down? If the fire is going to hit the slope and race up to the ridge, and the heat collects at the ridge and pools there, where would be the best place to locate your sprinkler? At the ridge. And what is the best way to throw that water? Down the slope of the attic. And that's how we came up with the idea for the attic sprinkler. After those 8 tests, we came up with our own sprinkler. We have 3 different types. A back-to-back type, which you run along the ridge, a single directional, and a hip. And I'll explain all 3 of those as we go. Here would be a cross-section of an attic. These red dots here represent existing standard sprinkler branch lines. What would happen in the fire test? The heat would start here at the eave. That's the point of ignition. It would race up past those branch lines and eventually pool at the ridge. So what we did is we created that sprinkler, that back-to-back sprinkler, installed right here at the center, at the ridge, and it throws the water down the slope of the roof. There's a number of firsts about this attic sprinkler that nothing like it's on the market right now except for this one sprinkler. The first to be listed for extended coverage in combustible concealed spaces. There is no sprinkler anywhere that can be used in concealed spaces or wood that's extended coverage. You can use it in both wet and dry systems. out here in Minnesota, I guess that's pretty critical. You can use it in the wood trusses, as I've said before. And this sprinkler is listed with specific roof pitches. So you can go anywhere from a 412 type roof, where the pitch of the roof rises 4 inches for every 12 inches it travels, to 1212, basically representing a 45-degree angle. Here on the bottom right is the type of sprinklers that we have. The BB1, BB2, BB3 stands for back-to-back. The BB1 is a half-inch sprinkler. Okay, and the BB1 1732nd is a 1732nd sprinkler. The differences in that sprinkler, the 1, 2, and 3, is the pitch of the deflector. You've got a pitch going like this, a 1212 application. Our engineers have bent the deflectors to go with the pitch of that roof. So if you have a 412 or a lighter pitch, you have a much less bend in that deflector. Okay, here's just a view of what the sprinklers actually look like. You see this slight pitch in this back-to-back sprinkler. In the 1212 sloping application, or the BB3, that deflector would be pitched quite a bit more. You have 3 various types. You go from 412 to 712. You go from 712 to 1012, and 12 to 12, or 1012 to 1212. You have 3 basic types of deflector. This one on the lower right is the hip sprinkler. What the hip sprinkler does is it corners a fire in a hip of a building. So you go to a point, here's a good graph to show how that would look. That would be the hip of the roof itself. The hip sprinkler throws in 2 different directions at 2 90-degree angles. If you have a fire here, the sprinklers operate and literally corner the fire into the corner of that room, or that attic application. So your back-to-back would be located along the ridge, going straight down. Your hip sprinklers throw at that 2 90-degree angles, so 2 different directions. Okay, this is all of your design data. And you get all your critical information on this. This back-to-back sprinkler can throw in a 60-foot span, or 30 feet in each direction. It's almost like having 2 sidewalls, but it's 30 feet. There's no sidewalls that can throw that far in any application, but it throws with the span of the roof. The single directional sprinkler can throw up to 40 feet in one direction. And the maximum throw on the hip sprinkler is 28 feet. So you have, no matter how big the attic is, if it's up to 60 feet, your hip sprinkler is going to work in conjunction with those back-to-back sprinklers at all times. Something to note is the maximum area of coverage for the back-to-back sprinkler is 400 square feet. Okay, that's the maximum allowable by NFPA 13. That 400 square feet can be, you can go over 400 square feet if you have a deep enough pitch. Let's say you have a 12-12 pitch, and you calculate how far that sprinkler is going to throw, because you have to measure it throwing in both directions with the slope. So you no longer have a 30 feet direction. With a 12-12 slope, you have much more. Your C angle, so to speak, on that throw. And the maximum distance between sprinklers are, for this particular sprinkler, is 6 feet. So you could end up with like 450 square feet. You'd have to decrease your spacing on the sprinkler. That's something to take careful note when designing this. All right, for all the designers who are going to actually, and the estimators who are going to actually determine what the flow demand of these sprinklers are, you just need this sheet. And it's really simple. It's the roof span itself measured on the flat. So if you have a 60-foot wide roof with a 412 pitch, you just go to this table. You've got, okay, it's 60 foot wide, and the pitch is on the far right-hand chart. It's a 412 roof. You'd use the VB1 17/32, and you'd need a minimum of 38 gallons per minute to flow that sprinkler. And you just use that chart for any type of slope that you might have. You can use a sprinkler up to any distance to 60 feet. Don't let it confuse you when it says, let's say the BB1 down here, where it says 40 to more than 20. If you've got anything over 20 feet, you have to use the 40 feet flow requirement for that sprinkler. Okay, figure number 2 is a good example of how to use the single directional sprinkler. Let's say you have a shear wall in a condo project that you're working on. It goes up one or both sides of the quarter into the attic space, and it's built all the way up to the structure of the roof itself. Well, that's a natural obstruction that you see a lot. That works as a perfect backing for the single directional sprinkler. It almost makes that attic space into like a mansard. Here in figure 2, you can see in that particular scenario, you can put a single directional on both sides, and the throw of that thing covers up to 40 feet. So if you see that shear wall configuration or any type of obstruction blocking off the spray from the ridge, you can go to that alternative of the single direction. All right. Here's the maximum spacing for a single directional sprinkler is 6 feet. The minimum spacing is 4 feet. That's a little bit different than what we're used to seeing in standard NFPA requirements. This has, if you're within the maximum and minimum criteria here, you're fine. When you use a back-to-back sprinkler in conjunction with a standard sprinkler, let's say just a half-inch head you're putting in there because you can't use the back-to-back sprinkler, the minimum spacing from that sprinkler is 6 feet because you still have to maintain the minimum spacing of 6 feet for that standard sprinkler. You have a lot of play on installation for the back-to-back sprinkler when it comes to the deflector distance. This has got a 16 to 22-inch deflector distance from the top of the roof. That gives you that will give a field installer quite a bit of room to work with and not have to worry about things being in the way, or you must meet that 6 inches maximum that is standard for the current standard half-inch sprinkler. Due to the trajectory of this sprinkler and the throws it produces, there's a 26-foot minimum distance between the attic sprinkler and a standard sprinkler. So let's say you have an attic greater than 60 feet and you have to add a row of standard heads. You must maintain at least a 26-foot minimum distance from that standard sprinkler. Okay, figure 7 shows a minimum of 6 inches from the face of a truss or any obstruction, pipe, truss. As long as you're 6 inches off of that obstruction, that sprinkler is going to work fine. Figure number 8 shows a 6-inch maximum distance from the center of the ridge to that branch line location. That's because typically you'll see in a trussed attic a vertical member running right down the center. You all familiar with what I mean by that? There would be a 2x member that runs right up and down here. Well, with that 6-inch play, you can move around the 2x4, the 2x6, and still have that installed, and you'll still get the 60-foot throw. By getting the listing for this sprinkler, we are now able to actually use CPVC in the attic spaces. That was our initial goal, and we got it. So if you're using central attic sprinklers, you can now run CPVC piping to feed the floor below the attic. So you can run the plastic in the attic. The only thing you have to do is put insulation over the pipe. You need 2 feet of insulation. If you're just running this thing across the bottom quarter of the truss, the only rule is 1 foot to each side. As long as the insulation is non-combustible, it doesn't have that paper backing on it, or it's not the spray type, that allows you to use CPVC piping. Just put a foot to each side. Unless you're running in a joist channel, then you can either fill that joist channel with insulation, or if the pipe's running in a channel, you can just cover that entire channel with insulation, and that meets the requirement for installing CPVC.
So what happens if you have to put standard sprinklers in the attic too?
You put standard, that's a good question, it's early. You put standard sprinklers, you can't use CPVC in the area that standard sprinklers are listed or installed. That's like, if you have an 80-foot wide attic, and you have to run, a row of heads, everything in that area is steel. But you still got that 60 feet. You can install the CPVC in that entire area.
Piping that the heads are on.
The piping that the heads are on, the attic heads are all steel. You'd be basically running your CPVC
The CPVC piping is for the floor below.
just for the floor below. Correct. It just allows you to install it in that area above. Now, especially here in the cold area, CPVC cannot be used in a dry system. So, I don't know how many of the attics here are heated. It's an option. The CPVC can be used in a wet system type application.
What, has there been any more information on how much insulation you need on a water-filled pipe? Using there was some studies there years ago. If you
manufacturers
run the pipe right on top of the drywall with the insulation on top, you're not going to have any freezing problems.
Well, liability-wise, I'm just coming up with that. Well, if you run X amount of insulation, that'll protect it from freezing. Too many cases where it actually froze anyway. We don't give a recommendation at all for it. Put this amount of insulation on top of piping, steel or plastic, and that will prevent it from freezing. This CPVC that we show on top, the insulation on top of the CPVC is for thermal insulation only. Okay, it's not for protecting it against freezing. It's just protecting it against the flames. There's a fire. Okay, here's a 60-foot wide attic. You've got one back-to-back sprinkler covering 30 feet in each direction. You've got one branch line. feeding that attic prior to your hips. You're saving from a standard application 1, 2, 3, 4. You're saving at least 4 branch lines. So you can see where the economical effect is felt by everybody by using the back-to-back sprinkler. If you get into a situation where you have roof members which are framed parallel with the outside wall, you can see these lines here represent a truss member. That serves as an obstruction. Okay, your sprinklers must flow in the direction of the truss. If you're going against it, you've got all those cross web members on the truss itself. That serves as too big of an obstruction. At any time you get into that scenario, you'd have to install standard sprinklers in the attic as opposed to the attic sprinklers themselves. Okay, you do have an option to use a single directional to cover this area here. I get a majority of the calls on the installation of these sprinklers. That single directional sprinkler is going to have a high pressure requirement. In that kind of scenario, I would typically advise, if you're going to sprinkle all of this with standard heads, I'd say just draw a line from that ridge point there and use standard sprinklers. If that's not a true hip where you can take advantage of the hip sprinkler, it would probably be more cost effective for you to use standard sprinklers. That is going to change when we come out with our new 1732nd hip sprinkler, because the pressure requirements are going to be so low on that, it's going to be very cost effective to continue using attic throughout the attic sprinklers throughout the attic. Spacing is real simple. About 3 feet from the ridge, as long as you're within 6 inches of any truss member, then 6 feet on center. You're done. You're using 24-foot lengths of pipe. It's real easy to do. Cut that main. 1 branch line and you're done. If you have the hips, well, what you would do is you'd measure for the single directional sprinkler 3 feet down on the slope, and then no more than 6 feet apart on the flat going down. That gives you an even distance of flows throughout the attic, in the hip and at the ridge. If you're using hip sprinklers, again, you'd measure 3 feet down from the slope, from the intersection here, and then a maximum of 6 feet on center with the slope to the end of the hip. You have a minimum distance on the hip sprinkler of 3 feet. So you're really getting well beyond the scope of NFPA when you use these type of sprinklers. Now if you look at this this figure 12 here, you can see the dashed lines representing a truss. Well, that's exactly how the flow of the hip sprinkler goes. So again, it's just pointing out how it can corner the fire. Anywhere within the range of the hip sprinkler, point ignition here, these 2 heads will eventually activate and push that fire and corner it and control that fire before the fire department gets to that. Okay, figure number 14 is something, especially here in the cold areas where you have insulation in the attics typically. The maximum of 60 feet is measured from where the attic ends. So if you have 1 or 2 feet of insulation here, and let's say you have a 62-foot wide attic, but you've got insulation now where the physical space from end of insulation to end of insulation is 60 feet or below, you can take that into account and just use that 1 row of attic sprinklers. Without that option, you would be forced at anything beyond that 60 feet to add a sprinkler row on each side. If you did have to use standard sprinklers in conjunction with the attic sprinklers. Let's say you have an 80-foot wide attic. Your first standard sprinkler would have to be 31 feet from the corner. Okay, and all that's doing is it's giving your hip sprinkler that's installed. If you recall, the hip sprinkler has a maximum spacing of 28 feet. And half of the minimum distance, 31 feet. And we gave that number to UL. They were happy with it. That's how I get that call a lot. Where the heck did you get 31 feet? These numbers. UL also required us to space the standard sprinklers no more than 7 feet on center. So if you're using the extended coverage back-to-back sprinklers and you want to go with standard sprinklers because the attic is, let's say, up to 80 feet wide, you can't take advantage of extended coverage standard sprinklers like that ELO 16 or something. You would have to space those no more than 7 feet.
How does this work in an attic where they got all these little dormers sticking in there?
That's a good question. Dormers, if they're framed on the wood joist members, you can sprinkler those separately. So as long as they're not interrupting the normal path of your standard truss, you got a truss and then you're building out a dormer on top of that, you can just pop a line down there and put a regular sprinkler and you're done. You follow what I'm saying?
Yeah.
Because the trajectory of the sprinkler is flowing down the slope. It's not like you're waiting for a heat pocket to go up against the slope.
I understand. I'm just curious. When you said just pop a head down there, we've got all dry systems in these attics.
Correct.
It seems to me like it'd be a maintenance problem.
In that case, with the dormer, you may want to run a dedicated line, so you're not dealing with the drainage and that type of application that's parallel with that dormer. And then typically, if you have one dormer, you've got a few going down the side of the attic. You could run one main or one branch line that's parallel with that dormer and feed it that way. So you can still take advantage of the attic sprinkler protecting the attic space itself, and yet you've got another line that's protecting the dormer space. Okay, our fire tests have proven.
What's the difference in RTI between standard and savage?
The RTI, we hate RTI questions.
I love them.
We like everything quick response or standard response. The reason why is RTIs can be so variable. If you open up a window in that room, the RTI value is going to change. So if I tell you I've got the lowest RTI sprinkler on the market, that's because my fixed area when I tested that sprinkler was ideal for that sprinkler at the time. We like to say quick response. It was tested per UL 199. Went through a controlled oven test, and the element operated within 14 seconds or less. If it operates more than that, it's standard response. Half of the sprinklers that we have not assigned an RTI value to because the variables are so different. And as soon as NOP is really pushing RTI right now too, especially with the new 1996 ROP, or Report on Proposals, that they've just published. And it's going to be a critical part of looking at these sprinklers. Where we as a manufacturer are going to run or bump heads into is Grinnell is going to say their RTI is 54. We're going to say ours is 53, and Star is going to say theirs is 51. When it's the exact same element, and they're all going to operate with it at the same time.
Well, I mean, that's the point. They're just shading, it
Right.
doesn't matter. If someone wants to use competitively, they want to deal with that calculation. I was looking at in terms of, you're looking at RTIs down at 50s, but that is standard over 200 or
Our standard sprinkler, the RTI, is about 212, which is a lot higher. We cannot give an RTI to, let's say, a concealed sprinkler because the cover plate's on there. The recessed application is going to change the RTI value, where still the response time of that element is going to be the same. So it's just one of those, we're getting that question a lot, and it's a good one. But I go through the same spiel with everyone. This is, how we try to categorize it. It's quick or standard.
we use it mainly just to get a reasonable approximation. As far as whether it's Brunel or Central, I mean, we just try to get a general range. Most of our calculations show that there's not much difference in response times playing that much with the RTI. If they're going to use it competitively, then it's a misuse of it. But in terms of just general categorization, I think that's what I was really looking for. Okay, thank you.
Again, the attic sprinkler, one branch line instead of 5. It's more cost effective. It works in a sloping ceiling or a sloping attic application. The test that we ran just basically proved that this 100 years of fire protection in a slope doesn't work well at all. And NFPA is looking at this test data now too. If we've proven that when you have a pitched ceiling, the fire just goes around the sprinkler and the branch line, there's going to be some changes made to rectify that situation. I don't know if you're all aware though, the 1996 version of NFPA is going to require quick response sprinklers in all light hazard applications. That's going to be a requirement now. There's going to be tables now you can utilize to reduce the remote area when you do use quick response sprinklers. This whole, everything that we're all used to for design applications is changing very rapidly.
Never made much sense to me when we look at protection in wood frame attics. We go into a building or apartment building as an example. We've got a foot of insulation over the bottom cord of the truss and non-combustible insulation. Yet on the roof deck is all combustible. The trusses are all combustible. The run sprinklers up there and all the water is directed down to the non-combustible area.
Yeah.
No one of those, even if those heads, as the heat going up the roof, set that attic head off, where's all the water going? It's being directed down.
It'll bounce off the roof and hit right down on the...
The deflector is set up that the majority of the water goes down.
You're right.
You're going to go up right ahead.
You're going to wet some
The direction of
insulation.
the water is to put most of that water down. In the old style sprinklers, you used to have the sprinkler head deflector allowed a significant amount of water to discharge not only down but up and around.
I agree.
It never ceased to amaze me that they never came out with a sprinkler head deflector for that type of application. The water would be directed, some of the water would be directed at the combustible area.
Absolutely, and also with a slope situation, you can't get heat pop. There's no heat there. It's taken off above it, seeking the highest level.
So just the highest level of the old way before these attic sprinklers, it directed all the water down.
Right. Any questions about the attic sprinkler?
How about some other sloped applications, like, for instance, under a stairwell or something like that?
Right now, this is just listed for a light hazard attic. We're coming out with, we really like these sloped sprinklers. We're the only one in that market right now, and we're coming out with a sprinkler called the ceiling sprinkler, where you can use it in a non-attic configuration, that would probably take that into account. You can currently use standard sprinklers under a stairway, but we are coming out with a mate to this attic sprinkler for other types of hazards.
When you say light hazard, can the area below the attic be ordinary, i.e. a kitchen and a golf club?
Yes. Yes. If you have a light hazard attic, you can use a sprinkler. It doesn't matter what you're protecting that level below
I was just
with
making,
ordinary hazard.
just checking the way you're using light hazard.
Right. Right now, it's currently only listed for light hazard. I have spent many hours on the phone talking with fire authorities, providing test data, and basically showing them that, standard sprinklers in this case, in this attic, do not perform as well as the attic sprinklers. So even though it's currently listed just for a light hazard attic, it very well is better than standard sprinklers, even in an ordinary hazard type of environment. And a lot of times, you agree to increase the flow to a density that's similar to an ordinary hazard. We've gotten very positive variances to use the attic sprinkler in ordinary hazard applications. Any other questions on the attic?
Say, Jim, with a lot of this new housing, now that, say if you were to take this typical attic where it shows the trusses, but instead of having a ceiling mounted on the truss, it's just exposed. Even though it's a light hazard situation, now it's no longer an attic, but it's just the actual living space itself. Do you still use these heads in that case then?
Not at this time. Right now, you must have a ceiling below the attic trusses themselves. It's listed only as an attic. We thought we were going to get a listing for this sprinkler for open areas also, but you all basically said you didn't test for that scenario, so you can't use it. Even though it would probably be better fire protection in that case. Right now, we can't. Again, we're coming out with a new sprinkler that you can use in open type areas, which is going to be ideal for the situation you just described. Okay. All right. I'm going to jump way out of the attics here into warehouse type fires. Okay, Central Sprinkler makes a storage sprinkler for just about every application. We have an ESFR sprinkler, foliage suppression fast response, a large drop sprinkler, a flammable liquid type sprinkler, and our ELO 231 sprinkler, where we came up with the idea and the concept for utilizing this sprinkler. The ELO 231 sprinkler is the best thing that's been out here since the 1732. I think that came out in late 60s? I'm not positive of when the 1732 started to be used. But that has been the standard for warehouse storage type applications for years. We made an ELO 231 sprinkler. It was originally called a D64. Basically, it just has a bigger hole. It's got a bigger orifice. Instead of a 17/32, it's got a .64 orifice sprinkler. By making that orifice bigger, we're able to push more water through it with less pressure. If you look at the graph here, we're starting off at 0.35. That's generally where you'll start to see your storage type applications, 0.35 and above. We're not talking 0.1 and 0.2 where you have light and ordinary hazard. We're getting into the to the big storage type fires. A half-inch sprinkler in a .35 application needs 39 pounds of pressure to operate. With a 17/32 sprinkler, you need 18.7 pounds. With our ELO 231, you need half of that, 9.4. And you can follow all the way across the graph. The half-inch just kind of gets redundant because you're not going to use a half-inch sprinkler in large density type fires, warehouse storage. You're going to minimum have 17/32. But across the spectrum, you save half of the pressure using the ELO 231 sprinkler. 0.6 common density in Group A plastics. 54.9 end head start pressure for a 17/32 sprinkler. 54.9. Okay, you hear that number, you immediately start thinking of pump. With the ELO 231, you only need 27.7, less than half. Okay, here's a good example of, with that gain in pressure, you can go the other way, where you can gain an increase in spacing. You would need, at 72 square feet for a 17/32 sprinkler, 28.4 pounds of pressure. You can increase the spacing of your ELO 231 to 100 square feet and still be more than a pound less than the 17/32. So you gained 28 square feet per sprinkler just by changing from a 17/32 to an ELO 231. Or you can leave the same spacing, let's say pressure is a problem, of 72 square feet for the ELO 231, you'd only need 14.4 pounds, half the pressure. But ideally, if you've got the pressure to operate the system, you want to increase your spacing. What do you get when you increase your spacing? For all of you contractors and estimators and owners, let's say you have a 40,000 square foot warehouse. At 72 square feet, with basically the same amount of pressure, for a 17/32 sprinkler, you'd have to install 556 heads. The ELO 231, with the same pressure, actually about a pound less, you only need 400 sprinklers. You're saving 156 sprinklers in a 40,000 square foot building. That is saving a lot on the bid. You can eliminate 156 sprinklers. You're saving quite a bit. You've got a 1,000,000 square foot facility or a group of facilities. You can see how much you're going to change and save throughout that project. Okay, any questions on the ELO 231 so far, on the savings of pressure? That's what you're buying. When you buy our product, you're buying that pressure. You're saying, I'm using your ELO 231 sprinkler because I only need half the pressure to operate that. That means you can go either way. You can save money on eliminating sprinkler from the design of the project, or you can eliminate the pressure required. If you had to double that pressure by going with the 17/32, your pipe sizes are going to increase. You may have to buy a pump. That's where the direct cost savings come in by using these large orifice sprinklers, or extra large orifice in this case. Okay, we ran a test with this sprinkler at Factory Mutual. Group A plastics, 0.6 density, 15-foot high storage. What we did was simulate exactly the test done, the baseline test, to create a density with the 1732nd sprinklers. Okay, that baseline test was done, sorry I don't know the dates, late 60s, early 70s. But it's what we've been designing to for the last couple of decades. Okay, this is kind of hard to see, so I'm going to have to point you through it here. What this is a test array. This area here is a double row rack array, standard array. This is just cardboard on the side as a what they call a target array, and this is another target array. If the fire spreads and ignites the target arrays, you fail a test. Okay. The red here is the point of ignition. It's where they actually started the fire within that rack array. After the fire got going and it started licking the ceiling and spreading, it took 29 1732nd sprinklers to put down that fire or to control it. 29. Those sprinklers use 1,740 gallons per minute. 1,740 gallons per minute. That's a lot of water damage. We simulated the exact same test. The circled green is our heads. 4 sprinklers operate. Okay. Not only do you have better pressure for that sprinkler, that bigger hole allows for bigger droplet sizes and the velocity of the water to attack that fire. It's better fire protection. 4 sprinklers operated and controlled a storage fire. Give you a direct comparison. The red is the baseline testing for the 1732nd sprinkler. Point of ignition. In 3 minutes, you were looking at spike temperatures of 1,800 degrees at the ceiling. 1,800 degrees. For you insurance people, that's a lot of heat on those trusses up there. That continued at no less than 1,500 degrees for almost 13 minutes. 13 minutes of those type of temperatures at the roof. Once those 29 sprinklers all operated, it started to finally control the fire. You were 15 minutes into the test and you still had temperatures of 1,000 degrees constant. And eventually it controlled it at about 18 minutes, and they were able to control that fire. This was a past test. This is what we used to base our design on for storage applications. You know that the roof structure was damaged. You know that you were flowing 1,740 gallons per minute for over 18 minutes. And we ran our tests. Again, 4 heads operated. They put so much water on the plume of the fire, it controlled it with just the 4 sprinklers. You see the temperature spike, went to 900 degrees in 2 minutes, and 30 seconds later, it went down to 200 degrees. After a few minutes, that fire was controlled. And for the first time in FM history, they didn't finish the test. And 5 minutes into the test, you're just flowing water from the sprinklers. They shut the test off after 15 minutes, just because there's no point to keep running. Just to further illustrate, here's that double rack array. The red is the damage that was in the array for the 1732nd sprinkler test. The yellow is the damage that the fire caused during the ELO 231 sprinkler test. So you can see in every instance, the ELO 231 is a better sprinkler. Okay. Any questions right now on the ELO 231 sprinkler?
Were the results the same using half-inch?
Half-inch wasn't tested. The pressure requirements are so prohibitive for that.
No, I'm talking about the ELO 231 with the half-inch.
Oh, 6 heads operated for the half-inch. And we ran 18 different tests. This was by far the best test we had. We had in one case 11 heads operated, just because of that was 20-foot high storage. What's used in the rack array inside of these things? It's polystyrene cartons, about a gallon jug that's empty. They put it into a cardboard container. About 8 of those they stack on one pallet. Okay, very combustible stuff. The whole point is to make sure that the fire doesn't spread to the target loads. The target array there, if that ignites, then you fail the test. All right, now I'm going to show you a little video on this test that we ran. Light the fire and the operation of the sprinkler. So you're going to see a lot of fire, you're going to see a lot of smoke, but not too much else.
Today's large-scale fire test is sponsored by Central Sprinkler Corporation. The purpose of the test is to determine if Central extra-large orifice sprinklers will provide protection equal to or better than that of standard large orifice sprinklers under comparable fire exposures. You are viewing the south end of the rack storage test array, which has been set up on a 5-foot-high platform on a 30-foot-high test site at the Factory Mutual Research Corporation Test Center. The array consists of a main double row segment at the center, flanked by 2 targets. 8-foot wide aisles separate the rows. The racks have divided into 3 5-foot-high tiers. And the main array is 2 pallet loads wide by 10 pallet loads long, and measures overall about 7.5 feet wide by 41 feet long by 14 feet high. Clearance from the top of the racks to the ceiling level sprinklers is about 10.5 feet. The center base and the double row rack are loaded with the Factory Mutual standard plastic test commodity. A filler Class 2 commodity is located at both ends of the main array and in the east target. The west target consists of cardboard sheets secured to wood framework. The plastic commodity is composed of 125 empty 16-ounce polystyrene jars packaged in compartmented cardboard cartons. 8 cartons comprise the pallet load. Automatic sprinkler protection will be provided by central extra-large orifice sprinklers. The 165-degree Fahrenheit rated 64 hundredths of an inch orifice sprinklers have been installed just below the ceiling on template by template spacing. A constant 0.6 gallon per minute per square foot discharge density will be supplied. Instrumentation installed for the test includes numerous ceiling level thermocouples to monitor gas temperatures, thermocouples installed in a steel angle located at the ceiling over the center of the array, velocity probes also located over the center of the array and extended 4 feet below the ceiling, and heat flux gauges located on the targets. Sprinkler operating times will be recorded, and water flow and pressure will be continuously monitored. Ignition will be by means of 2 standard half igniters located in the center flue space of the main double row rack, about 2 feet in from the east aisle face and adjacent to the bottom pallets. Final preparations are being made, and the test will begin shortly. The igniters are being lit. More ignition. Ten seconds. Just to the top of the bottom tier. We'll try some time. Seconds, on the top of the second tier, 10 feet high. 21 seconds, flames looking above the top of the array. 35 seconds, flames about 2 feet below the ceiling. 40 seconds, flames licking the ceiling. They still confined to the east side of the double roll rack. 47 seconds, flames have dropped back about 3 to 4 feet from the ceiling now, but they're now looking out the east face onto the top 2-tier cartons. Water in the east face, the ignition flue. 1 minute, flame is steadily licking 20 feet high. 1 minute 6 seconds, first sprinkler is opened. 1 minute 10 seconds, flames now back up to ceiling level. Flames becoming more established on some of the carton surfaces on the east face. 21 seconds, additional sprinklers have opened. No flames yet on the west face of the double roll rack. 1:30, some small flames looking out the top tier pallets momentarily at the top tier in the west face. 1:42, flames to the east face continue to spread over the pallet load border of ignition on the east face. 1:53, flames just below the ceiling. Looking only 3 to 4 feet above the top of the stack. 2 minutes, dense collecting over the ceiling, dense below sprinkler piping, and that's been driven down to the aisle, obscuring some of the view. 2:15, intensifying, continuing at the pallet load bordering the ignition flue. Heaviest fire is in the second tier. 2:30, flames appear to only reach above the top of the array from the east face. 245, no flames on the west base of the double row rack. 252, found there's some spillage into the aisle. 305, fire on the east side of the double row rack still appears to be confined to the pallet loads bordering the ignition flue, and then slightly to the south of the second tier. .325, smoke obscures the view above the top of the array, but there does not appear to be any fire above the top tier. In fact, it appears that there's only flame from the ignition flue extending up to the top tier. 345, dense lighter gray smoke is now being driven into the aisles, obscuring essentially all of the view of the fire. .4 minutes, sound of probably a carton or two falling onto the rack. The smoke layer extends at least 5 feet below the ceiling throughout the entire test site. .420, no view of any fire down the longitudinal flue. And smoke obscures all view down the west aisle. .445, cameras being moved to doorway of the test site as smoke is now extended to platform floor level surrounding the entire array. Smoke continuing to build. It's now extending down to the floor level of the 30-foot test site.
That's pretty much it on the test. 4 heads operated in that one. Okay. That exact same array, spacing of sprinklers, temperature rating, was done with 17 30-second sprinklers, and it took 29 of those to achieve the same results. That ring of sprinklers, the one head went off right into the plume, and then the 3 heads that forms that initial ring, which is so critical in warehouse fires, put an excellent rate of water on that fire and just really controlled it to the point where you saw the graphs earlier. In 5 minutes that you only had 200 degrees at the ceiling. Any questions on the ELO 231 at all? This same sprinkler you can use to eliminate racks in a rack configuration. You use the specific application of the ELO 231. If you have storage no greater than 20 foot high and a ceiling height no greater than 25 foot high, commodity classes 1 through 4, including Group A plastics, Group A and B plastics, you can eliminate rack sprinklers. So not only do you save on the pressure for the ELO 231, you can increase spacing if need be for the ELO 231. Decrease pipe size, eliminate a pipe. You can now also eliminate rack sprinklers. So for the designers out there and the people bidding projects and plan reviewers, you can always keep that in mind. If you have a set storage application and you meet those requirements, using this sprinkler, which is not an ESFR or a large drop, typically is what you use to eliminate rack sprinklers. This head can also be used in that category.
On those heads, has there been given any thought to give them good identification?
That's a great question.
When you go into these places on retrofit, you know what you're pulling out and putting in. I mean, I feel sorry for these fitters. They get up there in these little warehouses and stuff.
Real good question. In fact, Scott mentioned that earlier. How the heck with all these different products that everyone's coming out with, and the multiple manufacturers and all the different types of sprinklers, how are we going to identify them 5 years from now? Well, the NFPA 13, that same 1996 report on proposals, the entire committee had voted and agreed on something called a SIN number, or sprinkler identification number. Well, what it's going to do is I believe it's a 7-digit code. You can go up as high as 9 if need be, and you can read it, and an A is going to stand for standard sprinklers, and a B is going to stand for extended coverage sprinklers, and then there's going to be a number to give you the spacing requirements on that, and then a control number to tell you who's the manufacturer. So you can say, well, I don't understand any of these numbers, but I do know that C stands for Central. I can call them up, give them the rest of the number, and I can get all that data. And that's going to be enforced starting in the 1996 version of NFPA 13. All the manufacturers have bought off on it. Our only concern with this SIN number is that a lot of times you will have a sprinkler that has a dual type listing. Like we've got extended coverage sprinklers, which I'm going to talk a little bit about. That's quick response up to 18 by 18 spacing. But you can also have that same sprinkler in 20 by 20, but you lose the quick response ratio. So we got to figure out how we're going to put all that kind of information on the SIN number. Yes, sir.
Where are you going to put the SIN number?
On that very congested deflector. Right now there's everything is stamped on the deflector. What the SIN number is supposed to do is eliminate all but the FM and UL stamps that's currently on there. So instead of everybody writing SSU or SSP, half-inch QR or whatever that the stamping is on now, this SIN number is going to replace that.
Went off, you send the service truck out, and they go up the ladder and they pull the head off, and they don't have that yet. We don't have those things, because the service trucks aren't big enough to have 10,000 heads on them. So what really is going to happen? Are we going to go back down and just take a 3/4 inch or a 1/2 inch head and screw it in for the time being?
No. You can't do that. You should have, for NFPA 13, you should have a head box on the job site. I know, real world. The head box is always located right next to the sprinklers, or the area where the damage is. The problem has been addressed by making sure you're supposed to provide every type of sprinkler of every type of orifice, and that's where you get the replacement parts. What I suggest people to do is, okay, follow that branch line, go to the next head, and look at that one. Okay, get everything you can off of that. If there's a damaged sprinkler, if you're not sure it's the right sprinkler in that application, let's say if fire authorities go out and they're inspecting a job on a retrofit, and that head doesn't look right. Get everything you can off of that sprinkler. The frame arm, the deflector, the style that it's installed. And
that raises the question too, how can you say that that head doesn't look right when there's uprights and pendants that look identical when they're sitting on the table in front of you? And you can't tell the difference, and one's only approved upright, and one's only approved pendant. Can you say that head doesn't look right, you gotta see 35 feet in the air?
For
And a lot of
these
buildings,
installed,
this stuff, that building burns down, you know, they're not gonna sue Central, they're gonna say, use a box of heads. They're gonna send Jim here to jail.
when you have your inspection, let's say during, at the time you do your hydro test, your inspector should do a random check of the sprinkler system to make sure the right head is installed. I know that there are situations where you have, let's say I come from the Bay Area in California and had a lot of high-rise tenant work all the time. And you had every floor, you had 5 or 6 tenants, and each one of those, they were probably 5 or 6 tenants before them on the same floor, so you had so many different types of sprinklers. The only thing you can do is either get that sprinkler or the one in the same area, the same installation area, and get all the information on it. And then there will always be a manufacturer's mark on it, and you can call back to the manufacturer. I take those calls. Hey, I got a central head here. This is what it looks like. This is what it says on it. And then we'll give you an identification of it. There's no real easy answer to the case you're talking about, where the thing is up 35 feet in the air. You know, how do you identify that? I would say in that scenario, that would be like a warehouse situation. The inspector, when he goes out to look at the job, he must identify that sprinkler. That's critical, because you can submit anything, you know, lines and circles, but it's up to the inspector to ensure that the right product is being installed. Okay, we at Central have a very wide extended coverage sprinkler market. We incorporate both light hazard and ordinary hazard. Ordinary hazard used to have a maximum spacing requirement of 130 square feet. We've taken our technology and taken the NFPA's maximum 400 square feet and combined them. We've got ordinary hazard sprinklers now that can be spaced far more than that 130 square feet requirement there used to be. Okay, this would be for ordinary hazard. Again, the maximum used to be 130 square feet. Now we've got applications with we call it our ESLO. It's not an ELO. Our ELO sprinklers basically mean you have an 11.4 K factor, or a 0.64 1/100ths of an inch orifice. Our ESLO is extra super large orifice. Cornballish, I know. These have a 0.70 1/100ths orifice, so you have an even bigger hole to push that water through, and even less pressure required to make that sprinkler operate. You can go from 14 by 14 all the way up to 20 by 20, which is the maximum that's allowed by NFPA 13. Again, here's a comparison chart on the advantage of using the super large orifice sprinklers compared to the old standard type of 130 square feet. The 14 by 14 is not even applicable for the half-inch. We just show it on there just to give you a guide of the pressure requirements for a half-inch sprinkler. Going back to our ELO type sprinklers, similar to the ELO 231, with the .64 orifice. You can see the comparisons made to our super large orifice, where in a 14 by 14 application, you'd need 12.5 pounds of pressure to operate. In the I'm sorry, I got that reversed. The ELO sprinkler, you'd need 11.8 pounds to operate. The super large orifice, you only need 12.5. 11.8, 12.5. 20 by 20 application, it's illustrated very well here. You'd need 49.3 pounds of pressure to push through that sprinkler with the similar hole we just saw on the tape. You'd still need, at 400 square feet, 49 pounds of pressure. That's not real world type of pressures that you're dealing with in ordinary hazard applications. But with the super large orifice, you only need 30.4. It's more reasonable. It's something you can design to and live with without talking about super large pipe sizes and the possibility of adding a pump. Light hazard, it almost gets ridiculous in the pressure requirements for our super large orifice sprinkler. A 20 by 20 application, you only need 12.3 pounds of pressure to operate that sprinkler. I mean, that's nothing compared to what we've all been used to in the past. If you have a pressure problem where you virtually have nothing available on the street, you can crank back the spacing just a bit. Look at the difference between the 20 by 20 application ELO sprinkler or the Optima sprinkler and the 18 by 18. You only need 6.3 pounds of pressure. 6 pounds, it's less than the absolute minimum required per NFPA, but this sprinkler is listed with these pressures, so you can use them. If you bring your spacing down to 16 by 16, that's still greater than your standard coverage of 15 by 15. You only need 3.2 pounds of pressure to operate that sprinkler. That's this much pressure. That's it. By reducing the spacing on these type of sprinklers, you drastically reduce the pressure requirements. So you start off with the maximum spacing, needing very little pressure to operate the sprinkler, and the situation just gets better as you crank it down. So if you have very little water supply, this is a way to go. It can also help you if you have to go back and retrofit deteriorating water source areas. Let's say the sprinkler system was installed in the turn of the century, or the 10s or 20s of this century, and they've added 10 or 12 warehouses and a strip mall or something, and the water supply is nothing compared to what it was when that sprinkler system was first used. You can go back and retrofit the old system with the new type sprinklers with that larger orifice, and with the pressure requirements on here, make that system work again. Any questions on the ELO or the ESLO sprinkler?
In a room such as this, can you run the extended coverage out here for the half-inch and half-inch?
Yes, absolutely. The 1994 version of NFPA 13 states that you can have alternate orifice sizes in a room. It's an exception where they don't want you to balance the hydraulic calculations with a half-inch head, but you absolutely can use it in this type of situation, and that's an ideal example.
What's the minimum spacing between?
It would be per the sprinkler itself. You have to maintain the minimum spacing for the standard sprinkler, and you always have to maintain the minimum spacing for the large orifice sprinkler. I'm glad you brought that up because it brings up a point on minimum spacing. When we first came out with these extended coverage sprinklers, we had minimum spacing because it put out so much water of 14 feet, 15 feet, and in one case up to 16 feet between sprinklers. All right, so that would mean if you had a situation where you had to turn and you had to add a head, you couldn't do it. It'd be illegal. You'd be cold soldering that sprinkler. Well, now with our new ESLO sprinkler, we have minimum spacings of 8 feet for the upright and 9 feet for the pendant. So if you're using a 20 by 20 application, you can be 10 feet off a wall anyway. You're not harming yourself by cold soldering an adjacent sprinkler. Again, though, if going back to your question, that's a half-inch head and this is an extended coverage sprinkler. If that minimum spacing is 9 feet, you can't have any sprinkler whatsoever in that 9-foot range.
Okay, now I've got to ask another one along the same lines. I believe Central had stipulations on their larger sets for a while of a 5-millimeter bulb was so far minimum distance, and a 3-millimeter bulb was such a minimum distance. Have you actually changed those sprinkler heads so that
Yes.
doesn't apply? Okay, but so now are there sprinkler heads out there then that? I don't want to get hung up on this question, okay? Because
You're right. It's a great question, and it refers to his
Right.
question earlier. Absolutely, it's the same type of sprinkler, but it's got its own individual nomenclature. So it goes back to getting all the information back on it. It's not going to look the same as the new one. Our new ESLO sprinkler it's a third shorter. The deflector is barely over an inch wide. The old ESLO 20, we used to call it, had a frisbee deflector on it. Well, this thing was about yay big, horrible looking thing, but it did the job that we wanted it to do. So in this case, that refers back to that question. You can say, if you get me the information, or if Stars had the same thing, if you get all the writing and stamping that's on the sprinkler, you can identify that and let you know the parameters.
Well, I don't want to get hung up on it. I think we've already spent enough time on that part of it. But I think if you guys haven't, at Central, and they're not picking on Central, it was reliable setting up here, I'd say the same thing. But I think as a group, we'd like to express our concern about these types of issues. I looked at plans the other day of a building with less than 15,000 square feet where a contractor was 11 different sprinklers at that time. It's virtually impossible for an inspector or for the sprinkler fitter knows what he puts in. What Jim and John were talking about, the service guy goes out there, he's not going to have, he may buy reliable sprinklers, he's not going to have a central sprinkler to put in there.
Right.
But aside from that, the plan review person and the fire inspector, they don't have a chance. You can't, from here, we got to get a flashlight in the chair just to inspect this room and go see if those sprinklers are. So I guess all I want to say is maybe that
Scott, I agree with you 100%. Heck, we get calls where we're sitting here trying to identify our old products. Fortunately, we have a picture of it, and a sample of it. Exactly, right. Does it have a little bend in it? That kind of.
Okay.
Yes, sir.
I've got another comment. In some of the literature and the listing for extended coverage heads, it indicates that they're for use in smooth, flat ceilings.
Yes.
NFPA 13 has a definition of a smooth ceiling that includes some ceiling configurations that are not smooth by Webster's definition.
Right.
My understanding from UL is their intent for the listing is in fact a smooth ceiling as defined by, let's say, Webster, and not as defined by. And that's not clear in the literature.
That's a good point. What we did in the literature was refer back to NFPA 13, where it calls out for these sprinklers to be installed in a smooth, flat, horizontal ceiling. Where a lot of confusion is brought up is exactly what you're saying. There's a definition especially back in the 89 and beyond NFPA 13, of a smooth sealing construction. And then to further make things more complicated, they added things like bar joist construction, wood truss construction into a smooth sealing application. Well, what we mean on our literature is exactly NFPA 13. And a good point you brought up at the Webster's definition. If it's a smooth, flat sealing, that's how you can install that sprinkler, not in a smooth sealing construction application.
Thank you. So question 2 on these new now, the 0.7 orifice. I was getting awful close to 3/4 inch thread from what I'm putting in. Has there been any like integrity tests? I see in here it talks about you shouldn't go more than 21 foot-pounds of torque, but I was going to say being they're brass, it means they're also soft and it wouldn't take much damage. And think of even like a lot of applications where with so much of the electrical fields on now you have a lot of bats and stuff, so you got extra chemicals, atmosphere floating around like that. And just wondering how secure these guys are in the long run.
That's a good point. I didn't even think of that before. I'd have to defer back to the stringent testing criteria of UL 199, which these sprinklers must be tested to. It takes us a minimum of 4 months of submitting a sprinkler sample or a group of samples to the UL testing lab, and they do everything to that sprinkler. They decompose it, they subject it to corrosion tests, they put it in a friction type test. I'm not sure of the like you're saying, the soft alloy, the brass. That could be a problem, but I'm sure that must be covered in that. We haven't been getting any complaints of threads breaking off, but there's an ANSI standard, and I don't know what it is, that they must maintain, and these sprinklers do maintain that. But that's a good point. I'll bring that up to our engineering, because I don't know the answer. Okay. We have a concealed sprinkler out now. It's also a large orifice sprinkler. We're staying in the same family here. This sprinkler, it's an 11.4 K factor. You can use it up to 20 by 20 applications in a concealed environment. It's only UL approved, but this sprinkler is widely being used now because many of your architects like concealed sprinklers. I just wanted to make sure everybody was aware of this product being available. Again, with the larger orifice hole in this sprinkler, you have lower pressure, and you get in this particular product up to 1 inch of adjustment. So you no longer have to worry about adjustable drop nipples. You no longer have to worry about the old, on the thread section, there used to be an adjustable unit on our Model A Royal Flush sprinklers. This cap design has eliminated that problem. So you can be within 1 inch of rough in for the jib cord, and that adjustability feature will take care of it.
Is the thread on the cover adaptable to other manufacturers' threads?
No, it's not.
It cannot be interchanged.
No. It can only be used with the cap for that particular sprinkler. We have another sprinkler. I'm not going to sit here and put every product we've got, just things that are innovative and technologically they're advanced. That head is with that 1 inch adjustability plus the large orifice feature on it, and the spacing up to 20 by 20. It's the first ever, and that's something we like everyone to be aware of. Okay, getting out of extra hazard and ordinary hazard and light hazard. One more section to cover, and it's just 2 products. and that's in our residential line. So we've gone from storage fires to attic fires, to finally right inside your house. We've got a brand new product out. It's called a low flow pendant. And I just want everyone in here to know that this sprinkler is going to be seen primarily in every type of residential application that there is. It's got the absolute lowest flows on the market by over 1.5 gallons. And in residential applications, that's critical because you're usually dealing with a standard house meter on the street, and those meters can't not take extremely large flows. That's why you can't put standard sprinklers. It's one of the reasons why you can't put standard sprinklers. This is at a 3/8 orifice. Let me give you the flow requirements for it. As you can see, the 20 by 20 only needs 13.5 gallons per minute to operate with 2 or more sprinklers. So if you have 2-head calc, you only need 13.5 gallons per sprinkler. That's absolutely the lowest that's out there. We're 1.5 gallons lower than our direct competition. So for you plan reviewers, I guarantee you're going to start seeing this sprinkler out now. We've got a back order of 17,000 for this sprinkler once it's available. Yes, sir.
What does that cost of that sprinkler compared to other residential sprinklers?
Cost is very comparative. We're right in the same cost range as our existing GBR line, our glass bulb residential. You get more benefits out of this. So I don't know if there's a slight increase. I don't deal with the money at all. But the use of it, I've already found out from the calls that we get with the touchy situations you find in residential applications, that this head is going to eliminate a lot of problems. Let me tell you about 2 features that we don't have the listing for right now, but it's already gone through the corrosion resistant test. We're going to get it. This head will be available. I think it's available today. But these extra features are going to be available when we get the final UL test report signed and sealed. We can't sell those features until we get it. But I want you all to be aware that this will be the first residential sprinkler which has an intermediate temperature rating. Okay? For those of you who've got a house with a skylight, or you've got a possible heat source, or something. Right now, there is no residential sprinkler that is higher than 155 degrees, or a standard temperature sprinkler. That means no ambient temperatures can be near that sprinkler up to at temperatures of 100 degrees or more. Well, you guys are in Minnesota, that's not so much of a problem. If I was talking to a group from Arizona, that could definitely be a problem because it gets above 100 degrees in February out there. So that's going to be a very good feature. I want you just to be aware of it in case you've got a situation where you've got a head located too close to a fireplace or a diffuser. Now there's an alternative. Okay, just screw in this head and you're done. The second feature on this is going to be the first sprinkler in the pendant version that can be installed with the deflector 8 inches below the ceiling. Currently now, all residential sprinklers are required to have a deflector distance of no more than 4 inches below the ceiling. So we're doubling that distance. That's real handy if you've got a surface mounted light in your kitchen or something and there's nowhere for you to go. Generally, in the condensed housing or in a condo project with the light situations in there, you can't locate the head in a place where you're not going to have an obstruction problem. So you're either making it work for the architect or making it work for the fire department. Somebody's always getting in trouble in that mix. Well, this head can be installed 8 inches below the ceiling. So those are just some of the features I wanted you to know about the low flow pendant.
Strainer requirement,
It's below 3/8 where you need the strainer. We almost did a 5/16 sprinkler, but changed our mind at the last minute because that's a great question. That's the first thing that popped up. How many strainers are we planning on selling? And we decided we didn't want to go into that field. It makes it too difficult for people if they're not aware of that particular part of the code section. We could see problems coming out of it. So we just redesigned the sprinkler to make it 3/8. Again, the counterpart to the low flow pendant is a low flow sidewall. This has a K factor of 3.5, and again, it's a 3/8 sprinkler. This head does not throw the furthest, or 20 by 20 application like our standard GBR sidewall, but it is the lowest flow sidewall available. And it's got good range. It's 16 by 16 is a good range in residential. That's pretty much what we've seen as the ideal location for a sidewall. Sometimes you have a little bit larger room. Well, if there's other alternatives, you can go. But right now, if you have up to a 16 by 16 sidewall sprinkler, you only need 13 gallons a minute to operate this sprinkler. These are extremely low flows. Okay, right now, these are the lowest that there is. And we're right behind our competition who came out with flows 2 months ago. And they're a little bit higher than ours. So we waited just a little bit and we finally got our listing. So we're definitely the lowest, and it's going to be a while before you see any new residential sprinklers on the market. So these are hard, fast numbers that everyone here is going to be seeing in the very near future. The final feature to be known about this low flow sidewall is that in rooms 14 by 14 or lower, you have a 12-inch deflector distance. So how many cases do you know where you've got the crown molding? That molding up there, unless you're going to put a hole through that, you can't install a residential sidewalk currently. Right now you can go up to 12 inches down, so if you have a little soffit or a little bit of crown molding, it just gives you more design flexibility. Any questions about the residential sprinklers? I appreciate your patience. Thank you very much for listening to me and hearing about Central's products. I want all of you to know that Central would like everyone who doesn't have a catalog to have one. They're free. All you got to do, if you want, is give me your business card, or you can call. You've got my card in those handouts. You can call that number. We'll get you registered. Everybody will have an updated, registered catalog that you will continually get the updates for all our new products. You're just seeing a few of the things that we're coming out with. We've got a bunch on the back burner right now. In 2 months, we're going to be ready for another technical advance. I highly encourage everyone to get a catalog and to get registered, and you will continuously get updates. Yes, sir.
Are one of the items on the back burner a listed horizontal dry sidewall for ordinary hazard application?
Yes.
I would do it.
Yes, that's, in fact, that's been moved to the front burner. So,
How soon do you think we?
well, front burner means 6 months.
Before August of, we need it before August of '96.
When's the pipe go on the job? We're working on that. That's way up on the list of our, I was talking about a wish list earlier.
I'll hold you to it, I got you on tape.
Absolutely. That's something that there's a great market in. I answer 2 or 3 calls like that a week, what am I going to do? I need something like this.
What's happening, we're getting these, up here in Minnesota, we have these overhang areas, let's say truck docks or whatever, to where we try and get them with dry sidewalls. But the thing is, those are an ordinary hazard application, to where right now they're just listed for light. Unless we want to go with a dry system or an antifreeze system in the canopy.
We plan to be the first to come out with the ordinary version. There's a light hazard extended coverage dry sidewall version currently available, but that doesn't do any good in these loading docks. That's something we very much are pushing. So I estimate in 6 months we're going to have the product available. It's not idle talk. That's something we really want to get out there because the market is so big. Big market, we want to make it. Thank you very much.
Thank you.
Oh.